So, what was your name again? Callie, that's right. Callie, hope you don't mind me sharing this your story. So Callie, did you text me or email me? I don't remember. You texted me last night or yesterday. had an excellent question. Remember how I told you how the numbering in this is all off? Okay. So you're in your homework supposed to do like section B numbers like 1 through 9 odd, right? And I said, well, it's numbered wrong, right? So if you're supposed to do 1 through 9 odd, do you do the odds or do you do like the first one? I think you said there was one that started with 16, right?
Our homework started with number 16, so I was thinking like is 16 equal to 1 and
Yeah.
evens, or do I just go with the odds?
Yeah, so my reply to that was great question, you know. So just do whatever you want. Do every other one, or the whole idea is just for you to get practice. And the answers are, you know, provided online. So as long as you're doing problems and you're doing about as many as I've asked you to do in the homework list, you should be fine. There's no like, you know, you need to do that one. You know, we're not going to be that critical about things. So that seemed to be okay with you. Does that seem fair to everyone? Understand? Okay. All right, we're going to move on. We are solving linear equations. And we had stopped, order of operations we did, solving linear equations. I believe we stopped with this one right here. Yeah. Okay, so, y'all ready? Let's get going. Where are my little sticks? And I'm recording. Let me just do the first one, okay? And then I won't call anyone yet. All right, so I want to do one of these fraction problems, all right? So as soon as students see fractions, they start to freak out, all right? So let me start with number 20. So my recommendation is this. If you have an equation that has fractions in it, so long as it is an equation, I would recommend clearing the fractions. And what I mean by that is multiply both sides of the equation by the least common denominator. So look at this equation. You only have one denominator, right? And it's 2. So I would recommend multiplying both sides of the equation by 2 so that you would clear the fractions out. So here's how this would work. I would take this expression, I'm going to multiply it by 2. Really, I'm multiplying by 2 over 1. And then I have to multiply this side of the equation by 2. And on the right-hand side, I'm just going to write it as 2. I'm not going to write 2 over 1. Only reason I wrote it as 2 over 1 over here is because I want you to understand that the 2 is on top, there's a 1 on the bottom. Okay, now by doing that, I'm going to be able to just cancel this 2 and this 2 completely. And that's a good thing because that denominator will be gone. You won't have fractions anymore. And then on this side, to multiply the 2, you just have to pass the 2 through the parentheses. All right, so on the left side, these 2's are gone. This 1 doesn't matter anymore. And so I'm just left with this. 3 times t minus 7 equals, and then when you distribute through 2t minus what? 12? Are y'all on board with that? Any questions? So now this problem looks a lot more like one of these. You don't have those fractions anymore. Does that make sense? And we can continue this. What would I do next? Distribute, right? Distribute the 3 through the parentheses over here. So this would now become, what, 3t minus 21 equals 2t minus 12. All right. I'm already tired of hearing myself talk, so let's get to this. Hey, Adriana, you're up. I just wanted to know what you would do next here.
I would subtract 2 from both sides.
Subtract what from both sides?
2?
We're here?
Yeah.
2?
So we can get the t by itself.
Oh, 2t.
Oh, yeah.
Yes, 2t. Okay, you said 2, so you want to subtract 2t from both sides to get it on one side. Is everyone good with that? Because the first step, oops. Where were we? There. The first step was to like combine like terms. So there's nothing we can put together here. There's nothing we can put together here. So at this point, we try and isolate the variable t. So subtract 2t on both sides. Good. I agree. That looks like a good step. They'll cancel over here. On the left-hand side, Adriana, what would I have left? What would my new equation be?
1t minus 21 equals t.
Good. Good, good. So 1t, right? There's only 1t here. I'm just going to write that as t. And then minus 21 equals 12. All right, good job. Joseph. Where's Joseph? Okay. Negative 12, thank you. Yeah, she said negative 12. I didn't even look over there to see what it was. My fault. Negative 12, thank you. All right, Joseph. You cold, Joseph? A little bit. All right. I think I heard the wind chill in Minnesota is like negative 40 or something right now. It's crazy. All right, Joseph. We're trying to isolate t, right? Trying to get t by itself. So how are you going to do that here? Trying to get this by itself, right? Yeah. This is here. You don't want this here. So how would I get rid of this? What could I do to both sides of the equation? So this is subtraction, right? Yeah. So to undo subtraction, we're going to add. Yeah. So we'll add 21 here and 21 there. All right. Same thing. On the left-hand side, this goes away. We have t equals, now over here, this is going to be 9. So t is 9. The moral of the story here is that if you can clear the fractions, then you're going to be back to one of those problems. All right? So I think on the next problem, we're going to clear the fractions, and we're going to say, yes, it looks like one of those, and we're going to stop, and you could finish it up on your own. Okay? So let's take a look at this next one. Samantha? Right here, we have an equation, right, Samantha? And then we have a couple of fractions. So what is the least common denominator that you have? So you have to look at all the denominators and find a number that's common to all of them. So this one's kind of obvious, right? 7. So you're going to multiply left side by 7 and right side by 7. Now when I do left side by 7, what do I have to do? Because there's two things here. There's two terms, right? So when I do 7, the 7 has to multiply both, right? So I should probably put in parentheses, put the left-hand side, the two terms in parentheses. That way I'm sure to distribute the 7 through, right? And on the right-hand side, there's only one term, 13 over 7. So you only have to write the 13 over 7. You don't need parentheses around it. So I can go 7 times 13 over 7. Now, are y'all okay with the fact that I wrote 7 and not 7 over 1? Is there a question? Yes. Could you? Yes. The question was, could you just subtract 6 over 7 from both sides? Absolutely. I agree you could do that. What I'm trying to do is kind of approach this so that when we get to other problems, like let's just say that this was like 6 over 5, right? And then 13 over 7. Then when you subtract, right, then you're going to have to get common denominator. You're going to be messing with fractions. If you clear the fractions first, then you won't mess with fractions. There's, in my opinion, less likelihood for error. But yes, you could. Is that okay? All right. So 7 on both sides. Is that all right the way I wrote it? 7 here, 7 here. This is really 7 over 1 though, right? And this is really 7 over 1. So when I distribute here and here, what happens when I multiply these two together? What happens? What's that? The 7's cancel, don't they? And so all you're left with there is what? I need to move this. All I'm left with is what? When I multiply this times this. 7 times 6 over 7. You said these canceled, right? So you're just left with 6, right? Just 6. And then you still have to do the 7 times the x, so plus 7x. And then what about the right side? What happens to the 7s? Cancel out again, and you're just left with the 13, right? Okay. Now at this point, you are back up to one of those, right? So you would isolate the x, so now you'd subtract 6 from both sides, and then after that you'd divide by 7. Okay, so yes, should I stop or should I go? Continue. Just don't or do? I have to, is that what you're saying? I can't understand.
Yeah, I'm sorry, so that you have to continue that because that's not the answer.
That's right, but do you want me to? Okay. All right. Yeah, so yes, I was asking, do you want me to show you the rest, is what I was getting at. So I will show the rest of this one. So I want to get this by itself, right? So subtract 6. I think what you were answering was, would I accept that as the answer? No, I would not accept that as the answer. So subtract 6 on both sides, gone, and then we're left with what? 7x equals 7. And then divide both sides by 7, because this is multiplication. So divide both sides by 7, and you get what? X is 7 over 7, which is 1. Okay, I think your way was a lot faster. Yes. However, you start to run into some problems when you have something like, let's say number 23. See what I'm saying? Like there's no quick way to do 23 by just moving something over, and so, but it still has fractions, so we can still approach it the same way we just did the last problem. All right, we have this linear equation. It's got fractions in it. Colby. Where's Colby? No Colby today? All right. How about Leah?
Yes.
That's you. Oh, hey, there you go. All right, Leah. How do you say your last name?
Darianani.
Dariani? Say it again.
Darianani.
Oh, wow. Darian. Okay. All right, so what you see here, fractions, right?
For me personally, I find common denominator.
You do what?
I find
Common denominator, right? So that's kind of like what I want you to do when you see fractions in linear equations. Find a common denominator. Now, when you say that, you mean you want to get a common denominator and then subtract them? So you don't want to multiply through by something. Okay. So I'm going to tell you, do what makes you happy. Okay? If you are walking into this class and you feel super comfortable solving linear equations and you don't need me to help you out with it, stick with what you know. All right? But I'm going to present to the class like one way that we will do it, and that way we're all consistent. All right? I don't want to teach multiple methods. I still do think clearing the fractions is the cleanest way to do it. That's just my opinion. But stick with your way, Leah. So we're going to skip Leah. All right, Hayden. Where's Hayden? No Hayden today? All right. Valeria? Okay. So, are you okay with doing it this way? Like clearing? Okay, so what would I multiply both sides of the equation by? So you have to look at the denominators and see if you can find a common denominator between these two. So what would be a common multiple of both of those numbers? 35, right? 35. 35 is a multiple of both of those. So what we'll do is we'll write 35 here. We're going to multiply the whole left side of the equation by 35. Man, I just looked right into the projector light. I never do that. That's very bright. Okay, so I'm multiplying the left side of the equation by 35 and the right side of the equation by 35. I put the left side of the equation in parentheses and the right side of the equation in parentheses. Why? Why is it important that they're both in parentheses?
So you know to multiply everything.
The 35 has to go through to both of them, right? The 35 has to go here, and then it has to go here and here. We good with this? Okay, you want to keep going, Valeria? You want to tell me what the right side is? What's the right side? 35x minus 35. Good. Okay, we're all on board with that? The left side's a little more challenging, but let's just see how you feel with it. You want to continue? Okay, on the left side, I'm just curious to know what you get here and how you're doing it. So,
Well, I was thinking you cancel the 35,
uh-huh.
5, and then so that becomes smaller, so it's easier to multiply.
Okay. So, let me see. Let me write it down on the side here. We're trying to do 35 times 2 over 5x, right? That's the multiplication we're doing here? Okay, so you said you tried to like cancel it out? I think what you mean by that is you said, okay, 5 goes into 5 once, 5 goes into 35 7 times. And remember, this is really like 7 over 1? So what does that become? What number is that in front of the x now?
2, 4.
There's a 2, but there's also a 7, right?
Yeah.
And they're being multiplied?
14.
14x. Okay, 14x. Do y'all follow that? Because this is important. No?
Gives me over time.
Okay. We're doing 35 over 1 times 2 over 5 times x. That's what this means, right? When I do this times this. Okay, so when I do this multiplication right here, I'm actually just multiplying two fractions, just like we did earlier. Now, when you multiply, you could go straight across, couldn't you? You could do 70 over 5, but then you'd have to reduce the fraction, wouldn't you? So canceling is a little bit faster. If I go 5 goes into 5 once, 5 goes into 35 7 times, now I'm doing 7 times 2 over 1 times 1, which is 14x. Understand? That better? Okay? So this multiplication here to here becomes 14x. Now, here to here, let's see if we can do that one. What's going to happen there? So same sort of thing, right? We have 35 over 1 times 5 over 7 times x. That's what that multiplication is from here to here. We'll have a minus sign between them, by the way, because of this. So what would that be? I could cancel still, couldn't I? That's 7 goes into 7 once, and 7 goes into here 5 times. See, that's why you're finding a common multiple, because you know the 5 cancels here for sure, and the 7 will cancel for sure because 35 is a multiple of both. And so what do you have in front of that x now? 25x, right? So we have 25x. This good? See, no more fractions. Now you're working with an equation with no more fractions. So we can go through the process. We collect like terms here, right? These two can go together, right? So what would these two together be? Negative 11x equals, can you put these together? No, right? These can't go together because this has an x, this doesn't. So 35x minus 35. And now, what? Okay, so your approach, what you would do is leave this here, right? That's what you're saying, leave this here because you want to leave it positive. And so you're going to add 11x to this side, add 11x here, but then add 35 and add 35 to get rid of this 35. So let me see if I can do that all at one time. If I add 11x here, add 11x here, and then add 35 and add 35, what would happen? So it's kind of like I'm doing two steps at once here. These would cancel, right? Yeah. These would cancel. And the left side would be what? 35. And the right side would be 46x. And we would have one last step. That would be to divide both sides by 46. Right? Because this is multiplication, so we want to get rid of multiplication. We divide. The looks on some of your faces, I'm not quite sure what it is. It's either complete and utter, like, confusion or I don't know. But you have to let me know if there's something that's, you know. I'm trying to help you understand and learn something, so your task is to stop me from steamrolling you. I can go faster, but I'm trying to go at the right speed here. Okay. Are there any questions on any of these steps? Okay. Now, can we reduce that fraction? Is there anything that goes into both of these? We've already talked about how you could do this. You have to break that down to 7 times 5 and then break this down, see if anything cancels, but it doesn't reduce. Did you get the same thing? Yes? Okay. All right. You're going to need to practice these for sure to make sure you're clear on it. Let's see. Do y'all have this one in your notes?
There was some I had on the homework.
That was just like that? Yeah, we hadn't gotten to this yet, so if you tried it in the homework, it might have been a little confusing. All right, so these equations, I just did, where was it? This one, right? No. 23, right? So I'm going to let you kind of mess with the rest of these. I can't do every single example in class. We just don't have enough time. But work with those on your homework, see how it goes, and then you can ask questions on those next class. We're going to move on to something a little bit different, and this is really important. This is order of operations or linear equations. All right? Or. So look at number 1 and look at, number 1. Look at number 28 and look at number 29 and tell me what the difference is between those two.
One's negative.
One is equal and the other one is not.
One of them has an equal sign, which makes it an equation. The other one does not have an equal sign. Do you know what we call something when there's no equal sign there? We don't call it an equation. Anyone know what we call it? Expression. Very good. So this is called an expression. It's just like, blah, there it is, right? There's no equation to solve. It's just, here it is, right? Expression, this is an equation, which means you should get an answer. X equals something. So in this problem, we're asked to either solve or simplify, all right? Solve would mean that we are looking at an equation. Simplify means we want to somehow clean that up if we can. Make it look a little bit nicer. So looking at this right now, is there anything that I can do in terms of putting things together? What's that? Add the fractions. So these two right here both have x's in them, don't they? They both have an x. And because they both have x's, you could put them together. Just like if I asked you to take 2x and add 3x, you would say that that's 5x, right? But the difference is that those are both fractions with x's. So when you look at this, here's the way I want you to see this. This is really 1/3 times x plus 1/4 times x and then minus 1. So these two here are the same as this. So notice how I left the 1/4 x the same, but x over 3 I rewrote it as 1/3 x. That way we can work with these. They look more like one another. Now, how do you add those together? How do you add those x terms together? Common denominator. So this is basically like me asking you to do this. What's 1/3 plus 1/4? Okay, I'm going to do that, put them together, and then whatever that answer is, I'm going to tack an x onto it. Just like when you added 2x plus 3x. Aren't you really just adding 2 and 3 together and getting 5 x's? Here we're adding 1/3 x plus 1/4 x, so we're really just going to add the 1/3 and the 1/4 together. Whatever that is, we put an x next to it. So when we add those two together, we have to get a common denominator, which would be 12. So that means I have to multiply the first fraction by what? 4/4. And the second fraction by 3/3. And if you do that, you get 7/12. Like if you actually do this multiplication, put them together, you get 7/12. So this would become 7/12x minus 1. And we're done. That's simplified. So notice I'm not going to show this step because we have already talked about adding fractions and getting common denominators. I'm just going to trust that you could go from this up to that. And we're done. That's it. You box it. All right? This is the answer.
So we don't subtract the 1?
There's nothing to subtract from. You can't subtract these because this doesn't have an x on it. It's kind of like if I say, hey, what's 5x minus 1? You can't say that's 4x, right? This would only be 4x if there was an x here, right? Okay, now number 29, the difference between number 28 and 29 is that for 29 we do have an equal sign. And because we have an equal sign, this is like the problems we just did a second ago. We find a common denominator and multiply it through both sides. So what would be the common denominator here, Pepe? On this one, what would be a common denominator? 12, right? So I can multiply 12 through on both sides. So watch how this works. I'm going to do 12 x over 3 plus 1/4 x equals 12 times 1. Understand? 12 on both sides. Now, let's see if we can do this just by thinking through what's going to happen. What's going to happen when I multiply 12 times x over 3? You're going to get 4x, right? Because the 12 and the 3 are going to reduce, right? 3 is going to go into 3 once. 3 goes into 12 4 times. So when I go here to here, I get 4x, right? And then when I go here to here, what happens? I get 3x, right? And that must equal 12, right? 12 times 1 on the right-hand side. Add the 4x and 3x together, you get 7x equals 12. And then finally, you divide both sides by 7 to get x is 12 over 7. I realize I'm working a little bit faster, but we do have to somewhat speed up the pace a little bit. Is this all right? Okay. So the big difference between these two problems is that for this one, you get an answer, x is 12/7. On this one, you got an expression. And so the way you approach the two problems is a little bit different. This is a what? Expression. This is an equation, right? So you're going to go solve for x here. Here you're just going to try and put these two together. What about 32? Expression. 33, equation, right? Okay, let's just look at those last two. Let's see here. $32 is a little weird. Emily? Where's Emily? Emily, does 32 look a little weird to you? It's an expression, right? I'm supposed to somehow simplify this. So Emily, do you have any idea what we might be able to do here to make that look a little nicer? Just take a swing. What do you think? Good. I'm glad you took a swing. So just distribute the 3 through. I think that's what you meant, right? Let's try that, everyone. Let's distribute the 3 through. you get 3x minus 9 over 2 minus x, right? You all agree with that? Okay. Now, a very important property of fractions. Very important property I'm about to show you here. Do you all agree with this? Do you all agree with that statement? When we were talking about adding fractions together, a couple of days, first day, right? We said if we have the same denominator, then all you do is add up the tops, right? So if I had like 3/7 plus 1/7, this would be 3 plus 1 over 7, right? So 4/7. That's what would happen. So this is kind of like a symbolic way of representing what we just did, right? So check this out. If I start here, if I start with two things on top of a number, can't I go backwards then? Can't I go from here back to that? I could, right? I mean, it's an equation. It should work. If these two are the same, then writing this and writing that are identical. So do you see right here we have two things over the same number? I'm going to split those into two. Now, you'll see why in a second. I'm going to go 3x over 2 minus 9 over 2 minus x. Now, why in the world would I do that? Why would I do that? To combine the like terms. See how this was an x over here? And see we had an x over here? We should be able to put these x's together, shouldn't we? Right? Because there's x's and you can add or subtract them. But see, the problem is when it was written like this, well, especially in the beginning, that x was like trapped in here and this x was over here. So we need to somehow free it. So we first distributed through, then we split it into two fractions, and now I'm going to rewrite this like this. 3 over 2x minus x minus 9 over 2. So what I'm doing is I'm changing the order of things. I'm just sliding this x minus x over here next to this one and putting the 9/2 in the back. Does that make sense? Sure? Now we should be able to put these two together. Savannah? Where's Savannah? Do you know how to put those two together?
Technically, you can put like x over 1.
Yeah, this is like x over 1. So this is a 1 in front of that, right? So you're really just going to be subtracting like 3/2 and you're going to be taking away the 1. So like this. That'll be the number that's in front of x. Whatever this number is minus that number. And to do this, you could do like 2 over 2 here. We get a common denominator. So change that to 3/2 minus 2 over 2 equals, and what would that be? 1/2. So this expression up here, when we put these two together, becomes 1/2 x. 1/2 x. And then minus, we still have 9/2 there. And we are done. And we're done because you can't combine anything else together. How does that compare to number 33? Do we have questions here? Sure. How does that compare to number 33? How would you solve number 33? Michael? Where's Michael? There you are, Michael. So number 33, this is an equation, right? And it has some fractions in it. So what could you do to solve that? Okay, what do you want me to do? So you distribute this through, yes? Okay, that I can do, that's legal, and I'm happy to do that. But in the problems that we were doing before, when we had fractions and we were trying to solve equations, I said try and find a common denominator, right? And multiply both sides by it. So what number could you multiply both sides by here, Michael?
Before you distribute?
It doesn't matter what order you do it. You could distribute first, or you could just multiply by both sides by the number. You'll get the same answer. So what number can I multiply both sides by? 2, right? 2. So let me do that. I'm just going to write it in here. I'm going to multiply 2 here, and then on this side I'm going to do the 2 next to the x like that. I know that looks weird, but I'm trying to save some time. So what happens on the left-hand side with those 2's? They cancel. That's the whole point, is that this 2 and this 2 will cancel. And so you're left with the 3 parentheses x minus 3, and on the right side you're left with what? 2x. Now distribute through the 3, and you'll have 3x minus 9 equals 2x, and then now you can just like move your x around and subtract 2x from both sides, and then add 9, and so next step would be subtract 2x, subtract 2x. This would give you x minus 9 equals nothing, and then add 9 to both sides. I know I'm working fast, but x is 9. So totally different ways you approach these problems if you have an expression and an equation. All right, so let's see. Now you should be able to go through all that homework now, see how it goes. Skip this part of the homework. Synthesis, compare and contrast fractions. Not quite sure what they want you to do there. All right, moving on. We're still doing review topics. All right, so we need to first understand what a polynomial is. A polynomial is an expression that has poly, that means many. This means many nomials. And a nomial is basically a number next to some variable, and that variable can be raised to different powers. It could be x, it could be x squared, it could be x cubed, it could be x to the 4th, it could be x to the 5th, to the 6th. But as long as you have a number attached to a letter with a multiplication between them, that right there is called a nomial, or actually a monomial. That's a monomial, mono meaning one, monomial. And monomial, yeah, okay. And now polynomial is just many of those together. So you see how each one of these is a monomial? Number with the letter, number with the letter, number with the letter. And then when you put them together with addition and subtraction, you get a polynomial. It's just some language here, okay? That's all that is. So we want to be able to do operations with polynomials. That means we need to be able to know how to add them, subtract them, multiply them. And fortunately for us, we do not need to know how to divide them, all right? Just 3 of your basic operations. So let's say I want to add these two, or let's say I want to do this operation right here. Take this polynomial and subtract this polynomial. Thomas? Any idea how we would do this? Not at all? Does it just look overwhelming to you? This minus sign right here, this is really a -1, okay? And so what you want to try and do with this subtraction is you want to try and get rid of the parentheses. Okay, you want to try and get rid of them. And just like we had before, like if you had 3 in front of x minus 3, you know how when we distributed, you no longer had parentheses? Same thing here. We want to get rid of the parentheses. But to remove the parentheses around here, we have to imagine that that's a -1 that can get distributed through to each of those. All right? Now, what about this parentheses? Can I get rid of this parentheses here? I can as long as I distribute the number in front through. What's the number in front here? +1. If it's not written, it's understood to be there. So if I take a 1 here and distribute it through, isn't 1 times anything just itself? So really, I'm just going to drop these parentheses. Nothing's going to change. It's only after that minus sign that everything is going to change. So here we go. This becomes 3a plus 2a squared plus 3a cubed. All right? And now I'm going to write these three, but I'm going to change their signs. So instead of a, it's going to be minus a. Instead of plus 2a squared, it's going to be minus 2a squared. And instead of minus 3a cubed, it's going to be plus 3a cubed. So now we have no parentheses. Anna? Where's Anna? That's what I thought. Okay. You know what to do from here? Yes. So you put them together. We call it collecting like terms. But yeah, put them together. So you can only put them together if they have the same power on the letter. So let's start out with the a's. I have 3 a's here. Do I have any other a's anywhere? I have a negative a. So what would be 3a take away 1a? 2a. So I have 2a. So this equals 2a. Now let's look at the a squareds. I have 2a squared, and I have minus 2a squared, don't I? They cancel completely. They're gone. So no a squareds are left. And then finally, I have a 3a cubed and another 3a cubed, and we're adding them. So how many a cubes will we have? 6 of them. So plus 6a cubed. And now that is simplified. You cannot put those two together. Okay? You have to have the same letter raised to the same power in order for you to put things together. Oh man, look at this one. It's got fractions in it, but that's okay. Can I clear the fractions? Can I multiply both sides by the common denominator? Can I? Do you see an equal sign in there? Do you see an equation? Do you see an equation? No. If there's no equation, you can't multiply both sides by the common denominator because there is no both sides. This is an expression. So there's no clearing of fractions. So we're kind of stuck here, and we just have to try and drop the parentheses. Does that make sense? Okay. So can I drop this parentheses? Can I just drop that parentheses? Is there a 1 out in front? Yes. Okay. This parentheses, can I just drop it, or do I need to worry about it? What's the number in front of this? A positive 1. So I can just drop the parentheses. So I'm just going to drop all the parentheses on this. And then I go and I try and collect like terms again. Boy, we end at 10:15, right? No, 10:45. Okay, I was like, whoa, we're almost done. All right, so that all right? Just drop all the parentheses? Collect like terms now? Matthew, Griffin? How many A's do you have?
2.
Okay, so what do you get when you put them together? This and this, right? So we get 9a. How about a squareds? How many terms do we have with a squared in it? 2 of them, right? Here and here. But now you have to take the 2, right? And you have to subtract 2/5, which means you're going to have to maybe come to the side here and say 2 minus 2/5, right? And they get a common denominator and do all that stuff, which is, going to take a little bit of time maybe. But trusting that you could do this, what would that turn out to be? 8/5. I mean, you could get that on your own. Is that all right? 2/1, common denominator, multiply 5 here, put them together. Okay, so we should have 8/5 a squared. Now, Matthew, we're done. Leslie? Where's Leslie? Leslie, hi. A cubes. We got these two, right? So what am I going to need to do on the side to figure out what those two together are? Like we did with this right here? What am I going to need to do for the a cubes? What's the number in front of this a cubed? We're doing 3 over 5, right? 3/5. And then what's the number in front of the other a cubed? This right here? So we're going to, and it's minus, right? So we're going to go minus 3. And if we have to figure out what that is, and that will be the new number in front of a cubed. Okay, and that means we have to get a common denominator and put these together. Does that make sense, Leslie? Sure? Okay. So yeah, and this, I mean, you have to work through this, okay? You have to sit here, get a common denominator, 5 here, and what would you get? Negative 12/5. That's what you should get, negative 12/5 here. I'm not showing that work. So to combine those together, you're going to have to be able to add and subtract fractions. So on an exam, I'm very unlikely to give you a problem where I say, hey, add these fractions together. I'm more likely to give you a problem like this because in this problem you have to add fractions together, right? So I can kind of kill a couple of birds with one stone if I give you a problem like this. Right? Okay. All right, let's move on. That was addition and subtraction. I think I'll skip 3 because 3, I'm just going to drop the parentheses here. Here I'm going to distribute a negative through, and then I'm going to have to do more fraction stuff. But that one's going to basically work out like this one after you distribute the negative. What does this mean, though? What about number 4? It says 4x minus 3 squared, right? Means 4x minus 3 times itself. This means 4x minus 3 times 4x minus 3. That's what that means. You have to multiply it times itself. And how do we multiply polynomials? Does anyone know how we would multiply those two together?
Don't you do like
FOIL, have y'all learned FOIL before? Show of hands. FOIL, right? So what does FOIL stand for? First, outer, inner, last. First, outer, inner, last. And I'll be honest, I'm not a big fan of FOIL. Now, I understand it comes up and it's useful, but see, FOIL works here. FOIL is first, outer, inner, last. But what about number 5? Can you do FOIL on number 5? Why not? Because you've got 2 things here and 3 things here. You can only use FOIL when you have 2 and 2. 2 and 2. You can use this. So it's cute and a lot of people like it. But can I just maybe have you approach it just slightly different way? Just for a moment, just like if you could be open to something new. What I'd like for you to consider instead is this. If you're ever multiplying a polynomial times a polynomial, polynomial times a polynomial, if you're ever doing that, just start with this one, okay? Start with the first one you see there, and just multiply it through the, the other one. So I have 2 things here. I'm just going to go here and here, okay? After you do that, move on to the second one, and then go here and here. And then you're done, all right? Like here, if I did that, I would go start with the first one, and then I go here, 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 right? Then I move on to the second one, and I go here, here, here. Does that seem pretty straightforward? Now, let's go back. If you're like, I don't like that. I like FOIL. You know, then that's okay. But you actually are doing this, the same thing. Because if you follow mine, the first thing you're going to do is this one and then where? To here, right? Isn't that the first ones? And then if you go here and you go here, isn't that the outer ones? And then when you go here and here, you're doing the inner ones. And when you go here to here, you're doing the last ones. So we're doing the same thing. It's just I'm not calling it FOIL. And my method works if you've got 2 and 3, and it also works if you've got 4 and 8. It doesn't matter how many terms. You're just going to kind of, you start with the first one and exhaust it through the other one. Go to the next one and exhaust it through the other one. Does that make sense? All right. Okay, now if you love FOIL, you can go back to FOIL. So let's multiply this. All right. And we need to get through these names because I'm kind of doing attendance off of this. Diego? Okay, Diego, what do I get if I multiply those two together? 16x. Close? No, close. You're not done though. X squared, good. Okay, so it's really like 4 times 4, 16, but then x times x, which is x squared. All right, keep going, Diego. You sounded like you wanted to do the next one. What's that? Minus 12x. Crank it out, Diego. I think you got this. Here to here. Minus 12x again. And then finally, Diego, plus 9. Because it's a negative times a negative, which is positive. So plus 9. Now there's one more step that Diego needs to do. And that is add like terms together. So these are both x's. We can put these together. So we've got 16x squared. And what is this together? Negative 12x minus 12x again is negative 24x plus 9. And we are done. Cameron. Cameron. Okay, Cameron, you get number 5. X times x squared is what you're doing first, and that's x cubed. I think I'm going to move this up here a little bit. X cubed. So plus 3x squared. And then, so plus 9x. Keep going, yeah? Okay, so where are you going to go to now? What are you going to use to multiply through now? The negative 3, right? Okay, so now you move to the negative 3. So we've done the x, now we move to negative 3. Now here, what do you got? Negative 3x squared, and then negative 9x, just x, right?
Oh, yeah.
Right, so negative 3 times that is negative 9x, that's it?
Yeah.
And then last one?
Negative 27.
Negative 27. Good job. Are there any like terms there? Anything you can collect together? Oh, wow. Interesting. What happens, Cameron?
You can add well, the 9x cancels.
These 9x's cancel because one's positive, one's negative, and 3x squareds cancel because one of them's positive and one of them's negative. All right. Interesting. For those of you who might remember, who've taken algebra at some point in your life, right, might remember this phrase, a difference of cubes. Ever remember hearing that? Difference of squares, difference of cubes, formulas. This is actually a difference of cubes. This is x cubed minus 3 cubed. 3 cubed is 27. So there's a formula that allows you to factor this, and if you factor it, it actually turns out to be this. All we've shown is that if you multiply it back out, you get to this. That's beyond what we're talking about right now. All right. So this one I'm not going to do, but I'm going to just talk through it. For this one, what you have to do first is multiply those two together. Okay, so you could do your little boom, 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 or you could do your FOIL to get that. Once you get that, you're going to just now drop this parenthesis by putting the minus through and then collect them all together. So it's like you do this step first, and it'll make it look more like this problem right here. You'll have minus something, and then this part right here comes from when you multiply those two together. All right? So I'll let you do that one on your own. And now we're going to look at some little word problems with some geometry in them. All right, so we need to establish a couple of things first, some language here. Do we all know what the perimeter of something is? The perimeter. All the sides added together. So it's basically the perimeter of anything is the distance around the object. So like if I want to know the perimeter of this room, I'd have to measure from that corner around to that corner, to that corner, to that corner, and back to that corner, and that would be the perimeter of the room. So if somebody gives you a triangle, and they want to know, write a polynomial that represents the perimeter of this, we want to know the total distance from here to here, and then from there to there, and then from there to there. If you were to add all those sides up, how long is it? So they tell you this side is that, this side is that, and this side is that. So what are you doing to find the perimeter of this then? Adding all those together, right? So you're taking 3x squared minus 4x plus 9. You're adding to it 2x squared plus 4x minus 10, and then you're adding to that 5x plus 3. Make sense? Just add all those together. Now, do I need the parentheses, or can I drop them all? This is P, the perimeter. Can I just drop the parentheses here? Yeah, there's a 1 there. Can I drop the parentheses here? Yeah, there's a 1. Drop it here? Yes. And now we would just collect all our like terms together, all our x squareds together, all our x's together, all our numbers together. And that would be our answer. Our answer is not going to be a number. Our answer is going to be a polynomial. And that would be it. We'd be done.
Can't you just do it how it is on the triangle? Like you can already see that 3x squared, and then there's 2x squared.
Yeah, I mean, you could just do it here. Say that and that, that. Or sorry, that and that together would be 5x squared. Is that what you mean?
Yeah.
Yes. I'm just trying to show you how this feeds into what we just did. We have polynomial plus polynomial plus polynomial. Would that be a what?
Yeah, it's 5x squared.
Oh, you want me to just put the answer? I'll just put the answer here. 5x squared, then what?
Plus 5x.
Plus 5x minus 2. Did anyone else work it out? I'm just making sure someone agrees. I haven't looked at it.
I got +2.
Plus 2?
Oh, did I say -2? I'm sorry. I have +2.
It's okay. Plus 2. All right. I will trust your answers. All right, look at this next one. So we are talking here about area. Area is different than perimeter. Area is a measurement of how much stuff is on the surface of something. So like an example is if I wanted to paint this board, I would go to Lowe's or Home Depot and buy a gallon of paint. And on the back of it, it would say that this gallon of paint covers 300 square feet. That's a measurement of how much surface area I can cover with something. So when you look at this, perimeter was distance around, area is stuff inside. Now how do we calculate the area of a rectangle? Somebody gives you a rectangle and they want to know how much stuff is inside, and they give you the length. I'm going to do L and W. The area is length times width. Y'all remember that formula? Length times width. The length of one side times the length of the other side, multiply those two together, that's the area inside. So here it says, find a polynomial that represents the area of the shaded region below. This is the shaded region. The dimensions of the white square, the dimensions of this white square are x by x. So this side from here to here is x, this side from here to here is x. Can anyone figure out how to set this up? I'll take a volunteer first.
You just multiply this to x minus 5, that's 2x minus 5.
So you're saying take this times this, but wait a minute, that would give me the area of the whole thing.
Yeah, so you put those in parentheses.
Okay, so let me do that. You want me to do 2x minus 5 times itself,
Yeah.
right? So can I just say squared?
Yeah. And then
Okay.
put that in parentheses and subtract the x squared.
And then subtract from this that box inside, which is x times x. So this is the area of the big box without taking anything out of it, right? If this wasn't here, then if I did this times this, that would be the whole purplish box. But then I want to take out the inside, and the area of the inside is x squared. You follow that? So I would do this first. And how would I do that?